Welcome back to Mr. Vaughn's classroom, where math is made easy. In this video, we're going to be looking at Unit 1, Lesson 7. We are going to focus on constructing squares. The learning goal in this lesson is to be able to use straight edge and compass moves to construct squares. We'll have two learning targets in this lesson. Keep these in your mind as we do the practice problems. At the end of the video, we'll come back and review these to ensure you understand everything you need before moving on to the next lesson. Learning target number 1 says that you can construct a square inscribed in a circle. And learning target number 2 says that you can construct a square using a given segment for one of its sides. Our first glossary term is angle bisector. This is a line or line segment that divides an angle into two equal angles. So in this example here, if we were to say that this angle was 80 degrees, then that dashed line is the angle bisector that divides it into two 40-degree angles. Next, we have circle. A circle is a collection of points that are all the exact same distance from the center point. So in this example on the right, the center point is O. Every point on that circle is the exact same distance from O. That distance is known as the radius and is shown here by the letter R. Next up, we have conjecture. This is a reasonable guess based on the evidence that you have that you are then trying to prove true or false. The next glossary term is inscribed. On the left, we have an example of a polygon that is inscribed inside a circle. In order for this to be true, all 4 vertices or corners must be touching the circle. On the right, we have an example of a circle inscribed inside a polygon. And for this to be true, every side of the polygon must touch the circle in exactly 1 point. Next, we have line segment. Instead of a line that goes on in both directions to infinity, a line segment has 2 specified endpoints and consists of all the points on the line between those 2 endpoints. Parallel lines are when we have lines that never cross each other. They could go on in both directions to infinity, and they would never touch or cross each other because they run side by side or parallel. If 2 line segments come from parallel lines, then those line segments can also be thought of as parallel. Next, we have perpendicular bisector. This is going to be a line that cuts through a line segment exactly at the halfway point and does so at a 90-degree angle. And our final glossary term for this lesson is going to be regular polygon. In order for something to be thought of as a regular polygon, all of the sides must be the same length, and all of the angles must have the same measurement. Now let's get started on the practice problems. Practice problem number 1. Which of these statements is true? All rectangles are regular polygons. All squares are regular polygons. All rhombi are regular polygons. Or all parallelograms are regular polygons. So let's remember what it means to be a regular polygon. This means all sides are the same and all angles are the same. So with that definition in mind, let's look through the choices. First, we're talking about rectangles. Rectangles do have 90-degree angles for all of their angles, but the side lengths do not have to be the same. So because the side lengths do not have to be the same, A is not true. Let's look at C. We have rhombi. A rhombus is a shape that has 4 sides the same and the opposite angles are the same. But not all of the angles have to be the same. So a rhombi could be a square, but it could also be a diamond. So not all angles have to be the same. Okay, just the opposite angles have to be the same. So C is not correct. Let's look at D. D says all parallelograms are regular polygons. Now, a parallelogram means we have 2 sets of parallel lines. But the sides do not have to be the same, and the angles do not have to be the same. So that means D is also incorrect. Now B, on the other hand, when we talk about squares, a square has 4 sides that are the same length and 4 angles that are 90 degrees. So B is the one that's going to be correct. A square is the only example in these 4 that is a regular polygon, because it is the only shape out of these 4 that must have all sides the same length and must have all the angles the same measurement. If you have any questions about this practice problem, please leave a comment below. Practice problem number 2 will be the last practice problem we do here on lesson 7. This diagram is a straight edge and compass construction of a square BACD. Not all markings are shown. The construction followed these steps. So let's trace out what they did in each step. Number 1, start with 2 marked points, A and B. So they drew point A, they drew point B, and they labeled them A and B. Step 2. Use a straight edge to construct line AB. So they took a straight edge and they made sure it went through A and B. Step number 3. Use a previous construction, meaning this line AB, to construct a line perpendicular to AB, passing through A. So they drew this vertical line on the left. Step number 4. Use a previous construction to construct a line perpendicular to AB passing through B. So they drew this vertical line on the right side that goes through point B. Step 5. Use a compass to construct a circle centered at A, passing through B. So they put their point of their compass on A, they put the pencil on B, and they drew the circle going through point B. Now at this point, we can answer the question they're asking. Explain why you need to construct a circle in step 5. So they're asking us, why did they just have us do that step that I drew in pink, where we set the point of the compass at A, the pencil of the compass at B, and draw the circle? Notice where this circle leads to. It leads us to this point at the top, which they labeled point C. By drawing the circle, we ensure point C is the same distance from A as B is. This makes our sides the same length. So as soon as we draw that circle, we ensure that segment AB is the same length as segment AC. And now when we go through steps 6 through 9, we can draw the other two sides being the same length, and we create a perfect square. If you have any questions about this practice problem or the previous one, please feel free to leave a comment below. Now, before we stop the video, let's go back, review the learning targets, and ensure you understand everything you need to before heading into the next lesson. Let's go ahead and review the learning targets from Unit 1, Lesson 7. Learning target number 1 says I can construct a square inscribed in a circle. So this is something you can practice either in your class or at home with a compass and a straight edge. Just remember that in order for the square to be inscribed inside the circle, the entire square needs to fit within the circle with all 4 vertices or corners touching the circle. Learning target number 2, I can construct a square using a given segment for one of its sides. Think back to practice problem number 2. Once we had constructed line segment AB and we drew the vertical perpendicular lines, we could then use a compass to draw the circle with the point of the compass on A, the pencil of the compass on B, and this ensured that our line segment AC would be the same length as line segment AB, and now we could finish drawing the square, and it would have all four sides of the square the same length, and all 4 angles at 90 degrees. I hope you found this video helpful. If you did, in the bottom left of the screen, you should see another video that YouTube is recommending. In the bottom right of the screen, you should see the subscribe button. Please hit that subscribe button, give this video a thumbs up, engage with a comment below, and I look forward to seeing you in the next lesson.